Hi, I'm going to explain the project topic rice production using machine learning. First, data collection. Here, we are using CSV file format for this project. We are using two data sets for worldwide and for Tamil Nadu. First, we see the data sets. This, this is the data set for worldwide, and second one is this is the data set for Tamil Nadu agricultural yield data. And second step, data pre-processing. It is a process of reducing noisy data, null values, etc. Now we see the source code for data pre-processing. It is a source code for this project. First we import the packages and then read the rights dataset.csv file and stores the dataset in a variable name data. This line in simply display the content of the data variable in the output console like this. Data pre-processing, it is a second step, and we have the 7 module in this project. We can see one by one and the source code in this video. Data processing data.shape. This line outputs a tuple containing the number of rows and column in the data frame. Number of rows and number of columns is in this is the output. Data.add function. This line output the first 5 rows of the data frame. Data.tail function. This line output the last 5 rows of the data frame. Last 5 rows of the data frame. Data.info function. This line provides some basic information about the data frame, including the number of null values in each column, the data types of the column, and the memory usage of the data frame. Data.describe function. This line generates descriptive statistics of the data frame, including measure of central tendency, dispersion, and shape of the distribution. Data.columns. This line returns a list of column names in the data frame. The column attribute is used to get the column name of the data frame. The next one is data isNull function.sum function. This line computes the number of missing values in each column of the data frame. The isNull function method is used to check for null values, and the sum function method is used to count the number of null values in each column. Data.unique function. Data.nUnique function. This line returns the number of unique value in each column of the data frame. The nUnique function method is used to count the number of distinct values in each column. Data.skew function. This line computes the skewness of each numerical column in the data frame. Skewness is a measure of the degree of asymmetry of your distribution. The skew function method is used to compute the skewness of your data frame. This line creates a new data frame called data1 by applying one-hot encoding to measure column in the data frame. One-hot encoding is a technique used to convert categorical data into numerical data that can be used by machine learning model. The getDummies function is used to perform one-hot encoding, and the columns parameter is used to specify the column. And this line displays the content of the new data1 data frame. Here is the output. The next one, this line creates a heat map using the Seaborn library to create To visualize the correlation matrix of the data frame, the correlation function method is used to compute the pairwise correlation between columns in the data frame. The anode equal to 2 parameter is used to show the correlation coefficient on the heat map. Plt.show function, this line shows displays the heat map that was created by the previous line. The show function is used to display the plot. Here is the output for this. And next one is data visualization module 3, histogram. First one is histogram. This line create histogram using matplotlib to visualize the distribution of value in various columns of the data frame. The is function is used to create histograms, and the parameter passed it to specify the column to use for this histogram. First, location of data location shows in the histogram, and data subject shows in the histogram in output, and then data dot measure, and then data dot year. These lines are create a counter plot using Seaborn to visualize the count of occurrence of categorical variable into the data frame. And the lowest data dot value. Counter plot. These lines are counter plot using Seaborn to visualize the count of occurrence of categorical variables in the data frame. The counterplot function is used to create counterplots, and the parameter passed to it specifies the column to use for this count. And then this one, def function total productive all years. This line defines a function called func function that takes in a parameter called total productive all years. The function definition is this is the output for this cell. Now I define this cell for in list. These two lines define a for loop that iterates over all columns in the data frame, starting from the third column index 2 and continuing to the end. For each column I, the code creates a new entry in a dictionary called total productivity all years within the key I. The value associated with that key is a new data frame created by grouping the data frame by year and summing the values in column I. This line returns the total productivity all layers dictionary from this function, which contains a data frame for each column in the data frame, where each data frame shows the sum of the values in that column for each year in the data set. There is output for this. And then this line creates a new data frame called year using the pd.dataframe function constructor. The data frame is created by summing the value across the data frames in the total productivity all years dictionary along the rows. Here is the output. Next one, in this cell we import the plotly module. So I use install plotly, and I want the upgrade format, NB upgrade format, so that I also install that. Now we run this. These two cells are run. This command install the plot library, which is a powerful visualization library that can be used to create inter- interactive chart, plots, and dashboards. It can be used in a variety of programming languages. Now, import Plotly. It looks in this. I run this and explain that. This line first import Plotly library, then a new data frame called year is created using the total productivity all year. Finally, a bar chart. A bar chart. This is a bar chart. A bar chart is created using plotlypx.bar function. The x parameter is set to the index of the year data frame and the y parameter is set to the total number of productivity column. The resulting figure is then displayed using fig show function. Here is the output. Now I run this cell. Uh, a new figure is created using plt.figure function with a specific figure size 15,5. A distribution plot is created using C1 sns.distribution plot function, while the np.log1p function is used to transform the value column to the logarithmic scale. Histogram equal to false is used to hide the histogram. Color equal to B is used to set the color of the line, and KDE KWS equal to shade true is used to shade the area under the curve. The x-axis label is set using plt.xlabel function. The y-axis label is set using plt.ylabel function, and the title of the plot is set using plt.title function. Finally, the plot is displayed using plt.show function. Here is the plot. The next one is this line first. Group the data frame by location and calculate the total value for each location using the sum function. The resulting data frame is sorted in descending order based on the value column, and the top 5 rows are selecting using index. Then a bar chart is created using the plot.px.bar function, while the x parameter is set to location and the y parameter is set to value, and the axis label are set using the labels parameter. Finally, the resulting figure is displayed using figure show function. Splitting the dataset as train and test set. It's equal to rise data area production crop year values. This selects the area production and crop year columns of the rise data frame using the double square brackets to create a new data frame, and y to select the season column from the rise data frame using the double square bracket to create a new data frame. X shape gives a number of rows and columns in a tuple containing. Y dot shape in y data frame the number of rows and columns. Then import a train test split from sklearn model. It imports the train test split function from the sklearn model selection module, which will be used to split the data into training, validation, and testing sets. It calls the train test split function with x and y as the input data and specifies a test size of 20% using the test size parameter. It also set the random seed to 41 using the random set parameter. The resulting output is 4 numpy arrays: x train, x test, y train, and y test. X train dot shape. Dot shape attributes of an numpy array returns a tuple representing a row column. Dimension of the first element is of the tuple is the number of rows, and the second column is a number of shape. X value dot shape and y. X by calling shape on xtrain and x value, you can check how many samples and features are in each set. Like that previously x y and y train dot shape y value dot shape is like the x1. This I run this cell. This code, the function takes into two arguments y2 and y prediction label. It computes the confusion matrix using the confusion matrix function from the sklearn matrix module, which returns a 2 into 2 matrix containing the number of true negatives, false positive, false negative, and true positive in that order. Ravel function. A Ravel function. A Ravel function method is called to flatten a matrix into a 1D array of 4 elements, which are the assigned to 2n, fp, fn, and tp respectively, and return the accuracy. Next, Navy Bayes. This code first import the Gaussian NB from sklearn module, Navy Bayes module, and the confusion matrix function from sklearn matrix module. It then creates a Gaussian NB object called NB and feeds it to the training set using the fit method. Next, it defines a list called model is containing to the NB object. It also creates an empty list called ACC accuracy to store the accuracy scores of the model. The code that enters a loop that iterates over the model list. For each model, it makes prediction on the validation set using the prediction model and compute the accuracy of the model using the get accuracy function defined earlier. The accuracy score is then appended to the accuracy list. Finally, the code creates a dictionary called accuracy using the model name and accuracy list and print it to the console. Random forest classifier. Random forest classifier. First, to import the train test place from sklearn module selection. Now I run this one and then this code implements a random forest classifier model to predict the section for the crop based on the area, production, and crop year. First model is imported from the sklearn library. Then an instance of the model is created with random state parameter set to 0. The model is trained on the xtrain and ytrain data using the fit method. The model is added to a list called model and an empty list called ACC is created to store the accuracy score of each module. A for loop is used to iterate over each model in the model list. Inside the loop, the predict method is used to make prediction on the validation set of x value, and the accuracy of the prediction is calculated using the get accuracy function. The accuracy score is then appended to the accuracy list. Finally, the name of the model is added to a list called model name, and the dictionary called accuracy is created using the zip function to combine the model name and accuracy list. The accuracy of the model is then printed out using the print function. Then model comparison, we compare the each model random classifier and Navy Bayes. To compare the performance of Navy Bayes and random forest classifier, we can use here evaluation metrics such as accuracy, precision, recall, and F1 score. Here model NB and RF accuracy. Here the loop function is used to iterate over each other models in the model list. Inside the loop, the prediction method is used to make prediction on the value set of x value, and the accuracy of the prediction is calculated using the get accuracy function. And accuracy is added to the ACC and print the accuracy in this model using the Navy Bayes and random forest. This is the Navy Bayes and random forest accuracy. This creates gradient density plot using the Seaborn library. To visualize the distribution of accuracy dot keys and accuracy value using the dictionary data frame after applying the natural logarithm transformation. Here's an this creates a new figure with the specified size using the matplotlib library, and this creates a density using library cbond library to visualize the distribution of accuracy of key and accuracy of value stores in x and y of in the list format. And here do the loop for loop using the for loop to iterate over each other. And this commands x label, y label and title of the plot display it using matplotlib. The x label is set to models and y label is set to accuracy and title is set to model versus accuracy. And last, here is the comparison between the model versus accuracy. Navy bears and random forest algorithms are used in this project, and here is the output. We see all this checking the IS production is year wise, checking for the IS production in country wise, and splitting the dataset training and testing, model implementation, Navy Bayes, and random forest algorithm. And we also compare the two models. This is the project overall output. Thank you.